At first glance, this question looks impossible, but let me tell you it's quite easy. All you have to do is think in terms of calculus. The derivative and the second derivative can tell you a lot about how many real roots there are. Let's take the second derivative to tell us about concavity. This is a quadratic, and its discriminant is actually negative. That means this quadratic is never zero. Also, the leading coefficient is positive, so the quadratic is always above the x-axis. That means the second derivative is always positive, and that means that p of x is always concave up. This tells us that p of x actually has a single stationary point, and that stationary point is the global minimum. In order for there to be no real roots, we need this global minimum to be positive, as you can see. Let's try to find this global minimum by differentiating and setting the derivative to 0. Observe that this cubic is actually a geometric series. So we can use the geometric series formula as long as x is not equal to 1, and of course x equals 1 doesn't give us a solution anyway, and then multiply it out and we get this. X to the 4 equals 1 has only two solutions in the real numbers. We only take x equals minus 1 since x equals 1 was not a solution. So at x equals minus 1 we have a global minimum stationary point. But what is the y value at x equals minus 1? Well, we just sub it into the polynomial. P of minus 1 is this expression, and it simplifies to minus 7 on 12 plus c. That's where the 7 on 12 comes from. And if you remember, we just need this global minimum y value to be positive for there to be no real roots. And so we need minus 7 on 12 plus c to be greater than 0, or c is greater than 7 on 12. If you enjoyed this video or learned something new, please consider subscribing. And also check out my other videos. Thanks for watching. I'll see you later.